dealing with a different kind of memory management. That is basically how I can store the database. Okay. So the one data which will be used or commonly used, or you are also used with the many programs, is the array. So as the name suggests, or you already know that, so it is a fixed kind of, I have, when I initialize an array, so though there is a dynamic array, we'll come to that afterwards. So there is a, but if you see in most of our programming language, I have to specify the length of that, okay, array length. And this is very important for us, okay, same type, okay. When you go for object array, I can have a different member of that, I can have a different item, but in the case of array, when I say array, there is a same type, say integer array I have. We will be now showing with the example with a single dimension, one dimensional array for example, but it will contain a only same type of elements, okay. So that is important for us, okay. It can't have a hetero kind of information there. Okay. So another main criteria of array is they are stored in continuous memory location. The name of that array is pointing to the first element, okay, as you know already. So I am incrementing the index of that, and I'm trying to, but again I'm referring with the array name. So array is name is a valid, and they are stored in a continuous memory location. This is very important for us. Okay. So this most of the data, why? Because it is simple to implement, okay. Data array structure is easier to understand, easy to follow. So you require to know these two terms. You already may be knowing. This is one is element, another is index. So what is the element of an array? It is an object, what it is holding. Okay, say for example, I have a array. When I say array, it is a container for me. Okay, so the outer container. So when I say array, these are the elements of that. Okay, and what are the position where they are located, or position of that is nothing but an index. Now in case of, if you are implementing by the C++ or C language, and you know that it is starts for array index start from 0, but if you go with the MATLAB, it start from 1. Okay, so be careful, in you can implement algorithm in many ways. Okay, so the index in the case of C++ it starts from 0. So though there are 4 elements, the last element, the element number, the position is index. When I say position is 4, but the index of that will be n minus 1. I think this is known to you, but still this is the important one when we do any array operation. Okay, so be careful in knowing this information. Okay, so array is a container for me. All these elements are its a component, or we call this as element, and index is, in the case of your C++ implementation, it will be the one less than the number of element. Okay, so already we have seen this in the case of one dimensional array, we use a one subscript to get the elements or insert element or specify that. So the data type has to be specified, then the array name, then followed by the size of that. Okay, so what is this? This is an example what we have taken last class. So this is defines the type of element what it is going to store, and this is the name of the array. So, and this is the maximum size it can store. So these will be the randomly. When I say array, it is now in a general term, it is unordered. What do you mean by unordered? It is not sorted. It is not ascending or descending. It need not be. Any element can occur in random position. There is no ascending order or descending order of these values. Okay. And so only one thing you have to remember, though I've declared the size as 10, the number of the index position will go from 0 to 9, because it starts from 0. Obviously, there will be one less than that. That is what you require to remember. Now, with this basic information, we'll try to go for the many basic operation on the arrays. Okay. So to start with that, you know already this. I will not discuss much on that declaration. And in this case, when you don't declare completely, this is the though the size of that is 6, the whichever is not defined is assumed to be 0. Okay, this is how you can input the data into the array by using the array name followed by the square bracket in going for an index of that. So we can retrieve as well as assign an element to the array values. Okay, so these are the I think most of you used with this array kind of. Now let us go with the data structure kind of. So here we are going with the algorithm. Okay, so we don't go with the coding as such. Okay, so we don't use a coding of the your array, but we require to use if I want to implement this data structure, I require to use some coding. Okay, so that is the concept. So we'll go with the basic operation if you already it is being known to you. So these are the 5 important operation which we do with any of the data structure. So first one is very simple. You should be able to go to all the element. Okay, you should able to navigate to all the element. So one simple example is print all the array element one by one. So you can increment one by one and you can go to that particular element and print them kind of. Now what is this insertion? The name itself inform you that you are trying to insert or add one element into the whatever given structure, your data structure. In this case, it is an array. Now, this insertion can be at a given index. It can be at the beginning or at the end, or it can be at the given index. This is important for us. Okay. Now coming to the deletion, in this case you are increasing the data structure size, and deletion is you are deleting from whatever existing. So obviously the size is going to reduce. Again the deletion should be, we should able to implement an algorithm which can be able to delete a element, given element at particular index. Okay, this is important for us. Now, in the case of search, yes, the element has to be searched, a particular number, either index number or the element. You want to search particular element in that. So it should be capable of doing that. And update is nothing but you are trying to point to particular position and trying to insert or give the value to that. Okay, so this is called as update. But in the traverse or the search or update, we are not changing the length of the data structure. But in case of insertion, deletion, yes, we are going to change that. Okay, so with we will be going with all of them, all these operations. So it will be easier for you because it's already known with the array concept. So this is very simple. I will not go much in depth on this. So what I am trying to say this, there is a array which I named it as A, and it stores an integer value and a maximum size is 15. But I've declared, if you see, only few elements in that, not the 15 elements. Okay, so by default it is going to store other element as a 0 in this case. So the traverse is nothing but I have to go to each element. I can either print it or I can add it. It is left to us. But I should able to have a algorithm where I can point each element. That is important. In this case, I'm just taking a for loop, going through all the element and trying to print out. Okay. So this is one example of going to each element and do some operation on that. So this algorithm is easier to know. You already know the concept. Now let us go for a insertion. Okay. Now what do you mean by insertion? As we already discussed, so it should be capable of giving an insertion, or we should able to insert a given element at the end, beginning, and or at any given index. Okay, now let us take one example. Okay, so I think last class I have done that. I'll just repeat it. So what is this insertion algorithm is going to do? We require to find out. See this, let array be a linear unordered array. That means, what is that? Unordered means the elements which we have kept need not be sorted in. It is not required to sort. Okay. So you have some maximum element. Maximum is a value what you wanted to store. So the name of the array, let it be LA, okay, linear array. I just kept a one array name for this. Now what is n in this? Number of element. So what is this k? K is nothing but where you want to insert the index. It can be a 0 or it can be end of that, or it can be at the any of the position, but it should be less than or equal to n. Now why this less than? Because you have already told n is a element of that. Okay, so the item is nothing but where you want to insert that. Okay, what is the element, you the value what you want to insert. Okay, so let me take one example. So this is the unordered linear array, one array I have taken. Okay, they are ordered here, and this is the index of that array. So zeroth position, you already know this 31 is stored, and at the fourth position it is 1. So the number of element in this is 5. The index is going to start from 0, so it is going to end by 4. Okay, so say for example I want to insert, okay, at the k equal to 2. That what do you mean by this k equal to 2? K is 2 is nothing but a, here it is the index of this. Okay, but the position is nothing but a third position. Okay, so position is more than the one more than this index. Okay, that is what you require to remember. So what I have to insert? I have to insert 70, whatever the value you can think, at this particular position. So after the insertion of a whatever element, my array should look like this. Okay, so I've inserted at the second position, second index, and the value is 70. So what happened at that time? Whatever was there, it is being shifted. It is being shifted 1 plus. So 56 was there at the third, and now it becomes at the fourth. So 1 plus of that. Okay, so this algorithm, if you keep it as a 0 also, then also it should work. Okay, so if you keep it as 0, then all the element in the from this 31 to this will be shifted towards the end, and at this point the 70 can be inserted. If you go for this, it should be inserted at this position. This will be shifted, whatever there at this will be shifted at the end, kind of. Okay, so this is what you can think of a algorithm which should be working for that. So we'll just put a code. It is not a code, a complete code. It is algorithm kind of. Okay, so you can be present as a flow chart also. So what you can do it? What is the algorithm it is doing now? Let there is a one letter with j, which is n minus 1. Now why n minus 1 here? Because you already know the array index. Okay, it is one less than the your number of element in that. Okay, and n refers to the number of element here. So j is nothing but pointing at this fourth position. Okay, now what is after your insertion, number of element is going to increment by 1. That is what is being. Now after that n is going to be incremented. You can't put this third line before this 2. Why? If you increment here only, then j is going to point to the fifth. That is not, it will give the array out of bound index. Your array is going to be this one. So be careful in how you place that number. Okay, now what you're trying to do it here, you're going to repeat the step 4 and 5 while j is greater than or equal to k. Okay, so what you're trying to do it in 4 and 5. Okay, so what you've done in 4 and 5, let us discuss. So in this case, j is already here. Okay, now you incremented that by 1. So at the fifth position, you want to transfer this, basically the fourth one. J is pointing was here. Okay, at the j plus 1, you are sending this to here. Okay, so that is what is done here. Okay, then j is decremented by 1. Okay, so what is done now? Third, now it is holding the value 3. So then 3 plus whatever the third position, whatever the element is there, it is going to shift at the fourth position. That is what it is repeating here. So this third one, 4 and 5 steps are going to be repetitive. Okay, until you find j, whatever value is, it is going to be greater than or equal to k. K is nothing but where you wanted to insert here. Okay, now when we run this, so in a first iteration, your j is going to be the 4, which we have already said. So 4 plus 1, it is going to, with this element is going to shift it to this particular value. Next, this 56, that is 3 plus 1. This 3, whatever value was at the 3, is going to be shifted at the fourth position. Then at the third position, whichever is there here, 3 at the third position, this value is going to be shifted. So once it is done, j is become a 1, but k is nothing but a 2 here. So it is going to be, it comes out of this loop, and at the position this k, okay, it is going to insert the whatever value you have selected. So this will be inserted here and 70 is put in this. So this will be the your insertion algorithm. Any doubt in this? Is it clear? Any doubt? Okay, so if you don't have a doubt, I will just proceed. So hope it is easy to understand. This is how we are going to learn in our data structure. We will not go with the C++, say for example, kind of declaring a class or declaring any object, something like that. We will just give an algorithm for this, okay? It should be it is independent of algorithm, independent of any language what you're going to use, okay? So it should be implementable by Python or even Java or C or a C++, okay? That is what we require to do it here. Okay, now let us take another. If you understood this insertion, the next will be easier for you. What is that next one? Next one is nothing but a deletion, okay? So what is this deletion? Very simple. In a previous example, you added a one element, but in this case, what happened? Any doubt? Okay. So in the previous case, we have done the insertion. In the next case, we will be doing a deletion of that. Deletion is nothing but you are trying to remove one element. Okay. So what is, again, I'll take a same example. So LA will let there be this element. Okay. So I want to remove at this position. This again algorithm should able to delete at the first or the end or whatever the things. Okay. That should be independent of, it should be able to do that. Okay. So what should be my after deletion? What should happen? This element should go, and whatever was there at the third position should shift it to 2, and whatever was there in the fourth should shift it to 3. So one decrement, delete this particular whatever memory kind of, okay, you're trying to delete that. This is what it should happen. Now let us see what is the algorithm for that, okay? So what you're trying to do, you're starting at this point. Previously, you're set at the end of this, okay? So in the deletion, you are setting at the position where you want to delete, okay? So why? Because I don't require to store this element 444, whatever the value, okay? So you're trying to see until your element, it will go up to the all the length of this in array. You're just repeating that. So whatever was there in the jth, this position, okay, you're going to shifting at this, see this j minus 1. So you're shifting whatever was there at this position, you're just trying to shift it here. So that is what is going to happen here, and at the end of that you are decrementing the n. Why? Because here you can't decrement. If you decrement here only, then the algorithm is going to affect, okay? So after you complete all the things, you are decrementing the length of that. Okay, so that is what the your algorithm. So in this case, your array length is going to change. You are going to delete this particular element. Okay, and it works for either the deletion as the 0th or the your n minus 1 position also, because element number of element is one more than the your index what you are using in a array, in the say case of your C or a C++ nomenclature. Is it clear? Deletion, it is same as insertion. If you understood that insertion properly, this deletion is more easier than that. Okay, so deletion, you are deleting that content. Okay, basically that is what you require to understand. Okay, so with that, then we'll go for a search. Search is very simple. Okay, very simple operation. So what you're trying to do, you are starting from the 0th. It's the same as traverse, but in the traverse we have not put any if condition there. Okay, I'm not trying to match anything. So I'm just printing a content or something like that. But in the case of a search, I'll start from the index 0. Okay, starting with the element. Then I'll repeat this. What is this repetition? It says whatever element you are taking, is it equal to what you wanted to? Say for example, in previous case, if I want to take, say for example, I want to search for the element and the value as 1. Okay, wherever I find, I want to print the index of that. Let there be that a program. Then how I should do that? And this is my item. The value of that item is nothing but equal to 1 now. So I'm searching in the whole array. If it is equal to the value of the whatever the content of this array element jth element is equal to the 1. Okay, I'm comparing. Okay, so whenever I find that, I can print the index of that. Then if I, as soon as I find that, okay, I can come out of that because I have put a here the if condition. So I can, if this, if it is equal, then only do this. Else I can come out of this particular value, or I can print and come out of that. It depends on what you wanted to do. Okay, is it clear? If I'm not found, say for example, this is a worst case. The item whichever I wanted to search may not be there. Yes, any doubt? The item which I wanted to search may not be existing in the array. Then this loop is going to execute for all the length. That means this is a worst case for me, correct? Because it is going to execute for all the n element. So if the array element is more, the n is more, say for example 200 elements, then I have to, the number of execution will be, this for loop is going to execute for so many times. So the time it takes is going to be more. This is what you have to understand in case of data structure. Okay, so this is very simple one, and this is how you can do the search element. Okay, in this case it is a simple search case. We are not done any sorting or any kind of, we have just done a searching kind of. So I'm just checking if the given element whichever I wanted to give the item is equal to the whatever element value of that. It's very simple. But when it go to sorting or other complexity, again the complexity of that is going to be increased. Okay, we are not doing that now. It's a simple search operation. I hope it is clear.
Excuse me, ma'am.
Yes, tell me.
Yes, ma'am. Ma'am, can you please start the recording of the session?
I'm so sorry.
Thank you.
Is it fine that now I've covered a bit of that? Do you want me to repeat again? I'm so
No,
sorry.
no, it's fine. You can just start it from this point.
Oh, thank you for reminding me. Okay, I thought of. I'm so sorry. Okay, whoever not joined today, they may be missing some part of that. Okay, I'll just start. I'll just to have the recording purpose, I'll just take the few slides which are very important for me. So this is the insertion. So where we want to insert particular element. So you require to take a set the element here, okay, to the whatever position, and this is how the loop is going to execute. So whenever the loop is incremented, this particular set of value is going to repeat in this 4 and 5, and again it is going to end. So the end, when it comes out of this j greater than this, it is going to be inserted at this particular index. Okay, so if you understood the insertion, deletion is quite similar. So in this case, we will be deleting that particular point. Okay, so when you are deleting, we are not storing any place this. So we are just shifting the other element above this particular point. So that is the algorithm what we have discussed here. But remember, n is going to decrement here. Okay, so now this is nothing but a search operation. In the case of search operation, we are just making a if condition if particular item is equal to the jth, whatever element of this. So this LA, if it is a array, then if I want to search a particular element in this, say 1, then it has to be find out for all each of index, it will go and try to see whether this element value is equal to 1 or not. So whenever it finds a 1, it prints that time, otherwise it will come out of that. So if it is the complexity increases, if array size is going to be more in. So this is the worst case for the when we have a more number of element. Okay, so with this we'll go for the next one. It's again very simple one, that is nothing but an update operation. Okay, so the update operation is nothing but it is for very simple, same as your a simple equation. Okay, so if I want to update, I'm not doing any search this one or anything. I'm just saying that go to this particular position. Position, remember third position, but the index wise it is going to be one less in case of some of the programming languages. So in this case I'm identifying the index of this. I'm trying to go to this directly. I'm going to go to point to this position and trying to change this content of that. So very simple one. It is time what it takes also will be very less, because I'm not doing any search or insertion deletion kind of. It is just a simple going to that particular index and trying to assign a value to this. I hope it is very simple to you. It's updating the value. So it is known as updating the operation. You can see this update operation will be tedious in case of linked list. Okay, so we'll see that why. Okay, in this case array positioning the array is very easier. Okay, a of t, if I take array la of 2, I'm just making a la of 2 or something like that. I'm just assigning the value to this, because in array it is stored in a continuous values, so updating will be easier. But in case of linked list it will be going to be a tedious. We'll see that. Okay. Okay. So required index k position. Remember this point has to be remembered only for the your programming language. So third position, when I say, it should be one less than that. Okay, because index is going to be less than that one. I hope this is for our array. Any doubt in this array kind of data structure? We'll be using this array for some other, but this is for the as a insertion kind of or what are the 5 basic operation which we are going to deal with the your data structure. Any doubt? You can ask me. Otherwise, we'll go with the another concept. Okay. Now let us take the stack. Okay, stack is, you can say, uh, same as your array. It is also continuous whatever we have, but it has got a different behavior. We'll use it in a different form. So we call as an abstract data type. Okay, ADT. Okay, and it is mostly in all the language we are using, though we are not what you say specifically as the array we are declaring or something. It is there. It is within the your program. Whenever it has to run, it has to use the stack. So it is like parallelly running behind your programming structures. Okay, now it is named as a stack as it behaves. Okay, so you can see a card. Okay, there is a deck of cards, so one by one I can take out. Okay, similar to that. Okay, so it is, we'll see more on the this concept when we go for any of expression or arithmetic operation, how we do that. Okay, so this is you require to remember. Stack is nothing but I'm trying to it is okay. This is a very important point which you require to understand. We can only access the top element. This is very important in array. If you see, I can go to any position. Okay, array index I can give, and I can retrieve any nth element in that. Okay, but that is not true in the case of your stack. So in the stack, whichever is put, okay, it is being pushed, it is a container for me. It can extend any n number. Okay, it can be dynamically put in this, but I can, the whatever is put at the last can be taken out first. So we call this, you might have heard of last in last out, or sorry, first in first out, or other kind of operation, but in this case it is a last in first out. So whichever is at the top will be taken out first. Okay, last in first out. Remember these 2 points. One is I can access only top element, the last whichever is there in this. We can't access to the nth element here. Okay, and there is two important whatever concept we have, push and a pop. We'll see more on that. But these two important are the LIFO. It is LIFO is last in first out. Okay. Now, what is this last in first out? Then, with the to know that last in first out, we'll see when we go give a expression handling and all that. So before that, we'll see these information specifically for a stack. Okay. So the first important one is push. So the name itself it says I'm trying to put a some element into the stack, pushing that. Okay. So pop is nothing but removing it. That okay, taking out of that. Okay. So peak is nothing but I'm just taking a top element. Okay, top the peak is nothing but you are trying to you are just trying to take what is this element. You are not taking out, basically you are just peeking, you are just seeing what is there at the last nth element, what is there in that kind of. Okay, so E is full. This is nothing but it is a boolean whatever flag, you can see that is full or empty kind of. So it returns true or false for us. Okay, so it is mainly, you will see that how we will be using this kind of. So E is full and E is empty is nothing but it's a boolean kind of. We don't have a direct access to this, but we can use in our program embedded C or any kind of your, when we wanted to use operating system kind of, we'll be using most of this flags kind of. Okay, so internally these will be running whenever we take any kind of expressions or function. When I want to go from one function to another function calling, I'm storing the memory address. Okay, it is internally happened. Okay, so this is all happened in a stack. Now let us take two important whatever concept which you require to know with respect to stack. One is push and one is pop. First I'll give you the outline of a push, then we'll see how it is different in the case of pop. Okay, so I listed by side, at the end you can compare them. Okay, now let us take the first one, push. So it will check if the stack is full. Why? Because if it is already full, I can't put again one more element in that. So what it does, it will check whether that flag is not, it will say okay for that, then only I can put the information. If the stack is full, it produces an error. Okay. If the stack is not full because there is a place for that, then increment the top to point to the next empty space. So if I just show you the it's, if this is the container and see that this is not a full. Okay, so first what it does, it will see whether it will invoke that E is full kind of. Okay, so if it returns there is no error or is there is a place for this, then it will put the element here, and already the initially the top whatever where you want to insert, that insert position is nothing but a top. It is given by the value the variable called as a top, so it will be pointing at this position. So once you inserted this, the increment of the top will be incremented to the 1 plus of that, making that it is trying to insert. If I want to insert one more, then it will be top will be at the position where you want to insert that. Okay, so that is what it is doing here. So once you have inserted and top is incremented, now what it is doing, adds data element to the stack location. So top is wherever your data element is, now you have pointer, the pointer is changed, but data is not added. So you are trying to do with the addition in this. So the container contains now the element which you wanted to push. Then if it is done correctly, then it returns as a success. Okay, now let us see the same thing if I want to take out the element. Okay, see this, in this case, to put the element, I'll check whether it is empty or not. Okay, I want to see whether it is full or not. Okay, because I want to see whether there is a place to hold this element in the case of push. But what happens in a pop? You want to this is the first element which you wanted to take out. Is it possible there is no element in the container? but you want to take out the element. That is not going to be right. So first it will invoke this error, which we already seen, that is empty. So once is empty returns whatever the error. If there is error, then it will come out of that. If there is no error, that means it contains some elements. Then it takes the topmost, whichever is pointed by this whatever the variable is going to take out that particular element here. Okay, so that top is being taken out, and now in the previous push case you are incrementing, now you're decrementing. Yes, because it is you removed that particular element, so it is going to be 1 minus of that. So once you have completed this, your return is going to be successful. Is it clear? So in this case you're checking for the full or not. In this case you're checking for an empty or not. Okay, it's very simple concept. You're in a case of push, you're trying to put into the container or a stack. In case of pop, you're taking out of the container stack. Is it clear? Is it fine? Hope it is clear. Okay, now let us take where I'll be using this. Most of the things you already know. It is basically you are trying to switch between the to and fro from the your function. Okay, I want to go for a function, then address of the function is retrieved and all that. It is push and pop is going to happen, and more often it is seen in an expression for parsing. Now, what do you mean by expression parsing? Expression parsing is any mathematical expression which you just enter, but the program has to understand there are some operator which has got a more dominance, or I can say to give an example, if a plus and minus and the star, that is multiplication is there, you know already multiplication will take a more precedence or more weightage than plus or a minus. So how we are going to indicating that is nothing but a expression parsing, or in this case we are making use of a stack where what all the order of your expression evaluation will go through the stacking. Okay, we'll see this, and this concept is very important. Most of your exams, or either in MCQ or in your any kind of viva or any kind, we use this expression parsing as a one of the understanding of your stack or how it retrieves. Okay, so we understand this concept. Now in the expression parsing, it is nothing but it's a way to write arithmetic expression. Okay, so we are putting as a different notation to that. So the commonly these three notations are there: infix, prefix, postfix. Okay, so to this prefix is known as polish, and in a postfix it will be known as a reverse polish. Okay, you first we require to know what these are. Okay, prefix. So the name itself, don't by heart this. Prefix means your all the arithmetic operations, a plus minus whatever the arithmetic operation is going to come, they will be preceded first. Okay, they'll come first, then you have all the our ABC or literal for that. In post it is just the reverse of that. So what will be infix then? Infix is the normal way of we write that. Okay, so in infix, okay, the operators are used in between operands. Remember, in between. Okay, so this is the way usual notation. I know that A minus B plus C. So our brain will take some appropriate. If the bracket is put, we just give a preference to that, and we'll just make a calculations to this. But this notation, observe, you have an operator which are coming in between either literals. Okay, that is what is known as infix. So most of what we write equations, all are most of the time, or most of the time, not every time, it will be infix notation. But that is not suitable for our computing devices. Okay, we require to give a preferences of kind of, we have to specify what is a preference for that. So we use two other notation, that is nothing but a prefix and a postfix. Now what you can see, this same example, if I take A plus B, if I want to know A plus B, this is represented by prefix like this. First will come a operator, then between what literal you wanted to carry out, which between what data type you want to carry out that operation. So the first is the operator, then the your whatever operand is going to come further. Is it clear? So we'll see more on this. Next is nothing but a postfix. Okay, so if in case of prefix you are getting a operator first, then the operand, but in the case of postfix it is just the reverse of that. So in this case, first the operand will come, then the operator plus, minus, or any kind of. Okay. So most of the time we will be using this postfix kind of notation. So we'll take one example. Okay, not to see how they differ. Okay. So this is the usual notation which you may be using in all our representation equation. We'll be using this kind of representation. Now, let us take one by one. Please understand, if you have any doubt, let me know that, okay? So, in this case, very simple. First is a prefix. Remember, prefix means all my expression, operand is going to come first. Sorry, operator is going to come first, okay? So, plus is operator. So, I'm going to put this and then the order in this, the way they are going to arise. Okay, so first we'll go with the prefix, then I'll come to the postfix. Okay, so in this case, though we have written a bracket here, we are not going to do that. Okay, so in this case of a plus b or here, we'll see that how it is being arranged afterwards. Okay, I'll give you example on that. So in this case, but when we write a prefix, we are not writing a bracket in the case of that, but we will put a preference on what to be multiplied. Multiplication has a more preference here, or the bracket, we'll see that. I'll define that, then I'll come to this. But what you have to remember is here, your operator is going to come first. Okay, the order of what is going to come, but that is not always. Then if this is written like this, then you can see operator has come in between. Yes, there is again the rule for that. Now why it has come, multiplication has the precedence, no doubt, but it has got a bracket also having its own precedence or priorities. So based on that priority, these will be occurring. So the operand can come in between your operator can come in between the operand, but there is some rules on that. Okay, so we'll see that one by one. But remember, if you see this all prefix notation, first is nothing but an operator. Is it clear? We'll see how they occur, okay? Because I have to define what are the more dominants in this case. So, but you remember in the prefix, all the operators are going to come first, okay? The first is going to be the operator. Then you come as an operand for that, on which you are going to operate, okay? Now coming to the postfix, just the reverse of that. The name itself, it says that it is reverse. Okay, so first you're going to get all the variables or whatever name of that, then the operator is going to come. Again, you can see there is in between the operands. Okay, again I'll define why it comes. Okay, there is some rules on that. So but remember, in the prefix you're going to get first the operators. In postfix you're going to last. Okay, at the end you will be getting most, or you all the cases you are getting a operand first. Okay, that is the main difference of your prefix and a postfix. Is it clear? We go one by one example and we'll see why for this we got this kind of representation. Okay, what are the rules for that? So to define that rule, I require to tell you some more information. Okay, so it is not very efficient way to design algorithm which use a infix. Okay, infix is nothing but the usual notation, the way we write. But in a programming point, when I want to program or use it for my programming, it is not a right way or it is not effective. Okay, so that's a reason we are either we can convert into post or a prefix. Okay, so the operator precedence, then we require to define these two concepts: operator precedence and associativity. This is two information which we require to focus on. Okay, remember two things. One is operator, which is going to be more dominant or kind of. Then it is what it has been associated with. Mostly it is with the brackets. Okay, whenever I define a bracket, it is associated with that kind of. Okay, we'll see that. Okay, so this is precedence. Now when you come to the precedence, you maybe already know that in your programming or in your this one, your multiplication has more precedence than the your plus or a minus. So whenever you find the expression like this, it is converted something like this. That means this information is calculated first, then it has been added with the whatever you have here. Okay, so let us take that precedence here. So remember, you have three rules for this. So one is exponential, or you have the power kind of, and a dollar. This will be having a highest values, and it is right associative. Okay, remember this information, right associative. Okay, then comes your multiplication and a division. Both are having a same order level basically, but these are the second highest. Okay, so if you have an expression which containing all these expression, first it will be evaluating your power or exponential kind of, then your next part will be multiplication and division is going to perform, then you have a addition or a subtraction. Okay, so this is the order of doing. Now say for example, I have taken one example here. Okay, so in I want to perform this a plus b minus c, and according to the rule, plus and minus will have the same order, actually same level of that, and they are the lowest, no doubt, because we don't have a multiplication or any other, so both will be having a same order, same level. In that case, what will be accessed first, which will be whether it will do a plus b or it will do b minus c. Okay, to overcome that, again they have use this associative. What do you mean by that? It is left associative. That means it is starting from the left. If you see, first it will execute this a plus b will be executed, then it will be going with the minus of c. So it is going to go in this order. Is it clear? This is very important to know. So the first is it has got a precedence and it has got a associativity. So in the precedence, you have three categories. The first level is nothing but your exponential or the power of that and a dollar. Next is multiplication or a division, and then you have a addition, subtraction, three levels. In case of, only remember this right association is there with the your exponential or power of that. Okay, in other cases it is the left associative. Okay, we'll see when we go for examples. Is it clear? First we'll go with the our post prefix. Okay, postfix, then we'll come to the prefix. Okay, now what is this postfix? Don't be scared by seeing this algorithm. Okay, I will first I'll highlight what to be seen in this particular algorithm, and we'll take an example and we'll come back to this algorithm one by one. Okay, so given, and there can be any arithmetic expression, I can represent by postfix expression y. Okay, x is nothing but given expression which is infix for us, and I want to convert into postfix which is y for us. Y is nothing but, so you remember y will take the first value of y will be nothing but a, is it operator or a operand? Can you unmute and tell me? In case of postfix, is it operator or operand? Yes, anybody? Student, can you answer to this?
Ma'am, could you please repeat the question again?
In case of postfix, is the first value of y. Y is nothing but an expression, okay, which I want to represent in a postfix. The first value of that is whether it is operator or operand.
No, it's an operand then.
Yes. So in a postfix, remember that the first will be your operand, not the operator. Say plus minus will not be there. So you will be having all the set of operand. Okay, that is important for us. Okay, remember that. Okay. So what you're trying to do, if I'll just go through this algorithm, don't be scared of this algorithm, okay? So just I'll go through and try to understand by the some examples with that. First, as the first line of this, you are trying to put a bracket. That is nothing but you're trying to say this is the starting of an expression, end of an expression, something like that, okay? So you are just pushing your stack with the opening and a close of that, okay? Just to have a and at the end you're adding a x, so you're starting the whole expression by going with the starting with this whatever the your bracket, okay? Then what you're trying to do is scanning this whatever the expression from left to right, so you're taking one by one, okay? And you're repeating all these values until it is empty. Simple for that, so I don't go again and again to this. It's very simple. If an operand is encounter, okay, add it to y. Why? Because y is nothing but a postfix and it starts with operand, okay? So as soon as you find first operand, okay, literal, say a plus b, take the first operand, that is nothing but a in this. So once I take, then you are checking for whether there is a left parenthesis, because parentheses have a high precedence, okay, the brackets, okay? So it will check for left is or a right left parenthesis is there or not, okay? So if it is not there, if operator is encountered, what is done? It will put into the stack. Remember, now the until this it is only the y, okay? Then comes a stack for you. So the moment operator is done encountered, it is put in a stack, okay? Then one by, we'll see that operators are, remember, operators will go to the stack, okay? One by one, we'll see that. And whenever the depending on a precedence which we have already declared, okay, precedence, you have, you know, already three type of precedences there. Depending on that, this will be pushed and a pop from the stack, okay? So once we completed, when it encounters the right parenthesis, or it will be taken out, two of them, okay? We'll see that, okay? I'll just, this is the a whole gist of your algorithm, okay? The first, it is going to, you have one expression y and you have a one expression x. X is nothing but an infix and this is a postfix. So it is going to start with your bracket just to indicate the start of a expression, end of a expression. So first it will encounter whether any operand is there, then it will put into y. If operator is there, then it will put into the stack, okay? Then we'll see how it is taken out, okay, with the example. Okay, is this slide is visible to you? Is it fine? Is it visible? Yes. Okay. Now this infix is nothing but, remember, this is the expression, the usual expression, but how I'm going to convert into postfix, okay? So you have certain examples here, okay? You have how many literal operand, A, B, C, D, E, okay? And remember, I have different precedence, okay? There is a plus is there, star is nothing but a multiplication, okay? So what happens? I'm going to start with A here. Next, I have a star here, okay? This is star is nothing but a multiplication. The moment I get this, again it is put into the stack. But what happened? Next we have a one more element, C, okay? So this is nothing but an operand. So operand is put here. But you know that the moment you find the next operator, you know that this is a high preference or whatever you have the same, the next element what you got in the stack is going to be the your division. See this line, okay? This particular line, two lines, At this point, it is a only operand is put in the C, okay, and a stack contains plus and a star. Okay, the moment it encounters the division, this division is compared with these two, whatever the values. Okay, what is the, both are having a same level actually. The division as well as the multiplication have a same what do you say, the level. So what it does, it puts this star into the postfix string, because you are now performing B into C basically, this particular part. Okay, B into C is performed, is going to be performed. Then this particular whatever the value, the division is going to be the next element in this. Okay. Okay, next you got a operand. Again, it is going to update in a postfix. Then you find the minus. Minus is a your operator. But the moment you find the minus, what happened? You are going to use these two. See this. This division is having a more priority than the your minus. Okay. And what about the minus and a plus? If I see, both are having a same level. Okay, so both of these two will be retrieved and put in here, and a stack is updated with the only the minus sign in this. Okay, next you find the operator, sorry, operand E, then E is updated here. Okay, then whatever is there, it is end of your expression. So what happens, whatever is there in a stack will be put at the end of this. Okay, so just to give you the idea, okay, just in a simplified manner, so you already know this. Okay, if I give a expression, you have this, especially for multiplication and a division, you have a same precedence, and plus and minus have a lowest kind of precedence. Okay, so how the expression is going to handle, it will find out this B into C. Okay, say for example, I put this value as M. Then what is carried out? M divided by D will be done. This particular whole part is going to be completed. That is, M by D is nothing but B into C divided by D is going to happen. Okay, now you have actually A, N, then the E kind of. Okay, again both are having plus and minus is having a same kind of precedence. So A plus N is going to carry it out. That is nothing but this whole expression. Then whatever is left out is going to be the L minus E. That is how it is going to carry out the your arithmetic part. Is it clear? Please confirm. I want to have a confirmation, because I'll give you some more example, but this is a bit confusing here. So let me know, is it clear for you?
Ma'am, it's clear.
Fine. Hello?
Ma'am, it's clear.
Okay, fine. So we'll take some more example. This is very simple compared to the one which we have. So you should able to say that this A into B should be done, executed first, then the whatever the multiplication part is going to be at the end of the, sorry, addition will be taken place at the end. So you should able to, now you should be, by seeing this one, you should able to arrive at this point. Okay, how it is possible? You should put the arithmetic your operand first, A, then the B, and you know between these two both are, which is more precedence is there, put that one, and then the operand, then the your operator. Is it clear? Can you able to make out connect this with the answer which you going to get? Usually this is how you get it in the your 1 marks question MCQs or something like that. So always go with, if it is postfix, it start from a operand. Okay, give a literal first, then go to the any of your operation kind of plus or minus whatever you have. Again you just use the whether which one is going to proceed in this. Okay, in this case very simple for us, because it is only multiplication and addition, and you know multiplication is more dominant than the addition. So you are going to put this. So what exactly is calculated? A into B is carried out. Then whatever answer comes, it is going to add it with the C. This is how you should be able to connect easily. You should be able to do it in the mind. I hope it is clear for you. Now let us take some more. Okay. In this case, now in a previous case, you might have seen I have a plus and a multiplication, but now I have got some more here. What is this? It is a parenthesis. This has more precedence over any of the value. This is, I'm just making a group of that. Okay, so we'll see what is going to be the answer for this. Okay, now student, you can interrupt me if you're not followed. Let me try to start with. So this is A. As you know, it is going to start from right, okay, left to right. So I'm starting with A here. This is operator. So the stack is going to be the, when it encounters any operator, stack is going to update here. Okay, stack is now star. Next element is B. So this has been updated. Star is going to be there here only. The moment it encounters minus, what happens? This is going to come here because it is more preference from that. So it is be there in a minus, this particular point. Okay. The moment it is going to encounter this parenthesis, this particular information will go to here. Okay. And whatever literal is going to come, see, then you have a plus, it is going to be updated here. Okay, until it will be waiting for this particular closing bracket of this. Okay, so you can see, if you see the stack here, it is waiting until the your this whatever the closing bracket of that. The moment it encounters the closing, this particular whatever operator is there within the brackets, okay, whichever we have put, that is going to come here. Okay, but you observe this bracket is not come. Okay, you're not added here bracket, then the plus, then the bracket. Okay, bracket doesn't have that information. Okay, so now once I have done this, in the your stack I have only the minus. Why? This is having a more preference. Okay, so it is there in a minus here. We are at this position. Okay, so we are trying to get this plus here. So the moment I got a plus here, so what happened? Both are having a same precedence. Okay, this plus is nothing. Remember, this plus is because of a bracket. Okay, now you encountered this plus here, this particular one. Okay, the plus one, now it will go to the stack. Why the negative, this subtraction come here? Because both are having a same precedence. So this whatever is there, it is going to come, and this is going to be pushed into this. Then the operand is going to, E is going to come. Anyhow, you know, the operand will be put into the postfix string, and whatever is there in a stack is going to come at the end. Is it clear for you? But remember, in the expression, you don't get any time the bracket. So why you got these to see plus and minus together? It is because of this. How you read this? If you put a programming this one, this AB is performed. This multiplication is performed first. Then this CD plus this particular information is performed. Okay, then what is happening here? Then whatever the information is now available, something like this. So first it is been performed, then this is also performed, then you have E minus this whatever, you have these two operators. Now depending on what both are having a same precedence, this the left to right, it is going to be performed. So whatever is there, it is going to be first subtracted from this, then it is being added with the E. Is it clear? When the bracket and all that parenthesis is going to come. Hope it is clear for you. If you have doubt, you can ask me. Is it fine, students? Okay. Fine. Okay. So now let us take one more example. In the previous, I've taken a parenthesis, but here it is a what is this? It is a your power of that. Can you tell me what will be the our end answer? Anybody? Try. So it should be starting from A, correct? Because it's the operand for us. So first you'll try to do the B. Okay, when it encounters the this one, this will be there in a stack. Okay, But the moment it encounters this, okay, so the whole game, the plan is going to change, because it is going to perform this power, okay, the whatever power this particular information is going to perform first, then the division of this, then the minus of this, okay. So that in a postfix, this is going to be the order for us. So as I told, now what is done, bc power, b power c is going to be carried out first, okay. Then whatever answer comes, that is being a divided by this information is going to do, okay. Then whole information is being we are trying to subtract the d from that. So your answer should be something like this. Are you able to connect? Are you able to understand this?
Yes, ma'am.
Okay. Please practice, because it requires some especially when now you can see so many parentheses is going to come. It is going to be complex, but it is not difficult, okay. Only you require to understand the association and as well as the precedence in that, okay. I don't go in depth of all these, but you try to start. Always remember, it is going to start with your operand here, okay, because in the next coming class we'll be seeing the prefix, okay. It is just the opposite of postfix, okay. So in this case, it is going to the operand, it is going to start with operand here, okay. All the literals, the first one is going to be the literal for you, and depending on a parenthesis, now the game changes here, okay. Same expression without the bracket, it is going to do it in different way. With the bracket, it is going to work in a different way. So that is come because of the stack, the way you put into the stack and how you pop from the stack, okay. So I don't give the, you can note down this answer, okay. Anyhow, your recorded will be there in that, but this is the how you should able to get it, okay. So I don't go in depth of this, but this is how you should able to get. Is it fine? So this is in the next example. Again, I don't go in depth, but the complexity can be high here, okay. So what is the complexity here? I have got a parenthesis, I have a multiplication, division, as well as the power. Now, can you, from your already known facts, what will be executed first among this? You already know the way of execution. Can you tell me which one, what will be executed here first? Anybody? Students, please. If this was a given expression, among this, what will be executed here? Whether the multiplication, addition, or division, or you have a power also, what will be executed first?
Within the inner parenthesis, I think.
No, among that again it will go to this actually, because the an inner parenthesis, within that you have e raised to f, right? This will be the more first it will execute this, okay. Whatever value comes, it will be d divided by that particular information will do, because it is a within the parenthesis. Then it will go in this order actually, okay. So this should be the your order of executing, okay. We'll see more, because this is where the game changer comes, as I told, because this is nothing but you have a bracket as well as the power. So this power is going to come here, okay. This power, okay, the power of your e raised to f basically, okay. E raised to f is going to work. Then the division is going to happen with the d. Then the your multiplication with the bc is going to happen. Then you have a minus with that. That is how it is going to start, okay. I will not go in depth of this. Anyhow, it is there in your slides whichever we recorded, but try to understand this, okay. This is how the order of in a stack it will be, and when it empties or put into the your this one, it is going to, and you can see this how many iteration it takes, pushing, popping, because so many every operand operations, it will make a place to put hold that particular information and take out that particular information. So push and pop is been regularly called in this, okay. So that is how you have the, so the complexity increases, obviously your stack operation also is going to be more there, Okay, is it fine? So today I will stop at this position. Okay, so any doubt, let me know, students. Is it fine? Any doubt? No doubt. That means either it's so easy, or you know everything, or you don't know anything, or you didn't understand anything. What is right now in this case? I don't know. Hope it is you understood the concept, but always, though it looks very simple, okay, you require to practice it. Why? Because it is the where you can get confused also. Okay, so whichever you understand easily, you get a confusion also more there, because that is true. Okay, so try to make a clarity in whatever you do that. Okay, so try to push and pop properly in your mind also, so that you can retrieve it properly. Is it clear? Is it fine? Any doubt? No voice only. What did you had a food or not? Nobody is asking question, or nobody is answering. Yes, students. Is it clear? Is it fine? No doubts? Hello?
No doubts, ma'am.
Okay, fine. So I'll stop today's class at this point, okay? Because next class I'll be taking with a prefix. Okay, so prefix is just the opposite of what we have done. So I don't want you to confuse with already what we have put into your brain. So pushed into your brain, I don't want to take out in a different way. So let there be rest. Okay, but try to recollect the information. So this is the infix. So the expression, usual expression. Postfix start from a literal. Okay, because in a prefix we'll see that it is just the opposite. Okay, so be careful with that. Pre, or how I remember that, okay, the wordings. Pre is always the operator. Okay, pre or post I've just given with the operator. In case of pre, the operator will be first. In case of post, operator will be the last. Okay, post kind of. Okay, so just remember that concept. And once we understood a post, it is just the reverse of that. Okay, we'll be doing a reverse of this, but bit confusing to you to understand. So I'll stop at this juncture. So next class we'll start with the this concept into the your stack, how it will be doing it. Then we'll go with the prefix of that. Okay, is it fine? Clear? Okay, fine. So you can leave. I'll be taking in the next class. We will be doing with the your prefix kind of understanding expression. Thank you. Thank you all.